So here we have the script to create the naive Bayes classifier. So first, let's create a new file, new notebook, and then import or install the MBA. Let's also rename this notebook as naive Bayes. Then let's add another code cell and copy all the required packages and run. Next, add the new code cell and we will now load our data set using the DMBA load data. We have here the delays DF will hold the data from the flight delays.csv. And we also show, we use the head command here to show the first four or first five records of our data set. We have the first five records are displayed. So we see now that delays DF have this columns, CRS departure time, career, departure time, destination, distance, flight date, flight number, origin, weather, the day of the week, day of the month, the tail number, and the flight status, whether on time or delayed. Next, we have the script to create now our naive Bayes and predict the class membership. So what we have here is we again load our data set, the flight delays.csv, and then we convert those that are categorical. We convert those record or those columns to categorical. So in this case, we have the day of the week. This column have numeric values, but this numeric values does not pertain to numbers. It's actually a categorical because this have different meanings. Like the four means that it is the day of the week is Thursday, and there's also one. If the value here is one, then that means it is pertaining to Monday. So two is Tuesday, three is Wednesday, and so on. So these values are not actually numbers. These are categories. So that's why this column is must be changed to categorical. So if you do your assignments later, you'll have to identify which of the columns that are needed to be converted to categorical. And then we also have to convert the CRS departure time. So this also is should be a categorical variable because this is the time. For example, 14:55 is 2 o'clock. No, 2:55 in that's the time, and then we want to convert this to categorical and round it to the nearest time. So this should be turned into 3 o'clock or equivalent to 15. And this one should be 17. This is 13. And this is 17. And this is 10 o'clock. So to do this, we will have a loop, or we just round the each of that using the round command and divide them to 100. So for example, the 1455 divided by 500, yeah, 1455 or 1455, you divide it by 100, the result is 14 point something, and we round it. Because of the round, it will become 15. Then each of that will be rounded. So that will be the new value of the CRS departure time. And then we convert the departure time to category. So this is how you convert a specific column. For example, the day of the week, we convert it to category. So this is the script to convert to categorical. So another script to convert the column into categorical variable. So here we specify the name of the column. Next is we need to identify which of the columns here, which among these are our predictors. So which of the columns do you think have the factor that will contribute to the flight status? It will those that are the factors that the flight status is on time or delayed. So we identified here the predictors are the day of the week. If it's Monday, Tuesday, they can be the contributing factor. And we also have the departure time. Sometimes the time is there's what we call a busy time and some lazy time. And then we also have the origin can also be a factor to the delayed or on time flight status. And then we also have the destination is also another factor, and the carrier. Then we have to specify the outcome of our classification or our prediction. Then this time we have the flight status. This is what we want to predict, whether the flight status is on time or delayed. Usually, the last column is our outcome. That's the outcome variable that we want to predict. Here, next to that is we get the values of x. These are the predictors, and y is our outcome. So next here is we want the classes, no? The classes or the values of our flight status are on time and delayed. These are the classes that we want to predict, the on time or delayed. Next is we split our data set into the training set and the validation set. So the training set are those data in our data set that will be computed, and then the validation set will be those data that we can use to test the accuracy, the correctness of the prediction. So here we have to do that, we have this script. We specify the x train variable, x valid, the y train, the y valid, and then we use the train test split command, specify our x here, data, and the y, and the test size is 0.40, and the random state is equals to 1. So 40 here means that the 40% will be, or the 40% of the data set will be allocated to the uh, validation data, and the 60% will be for the training. Next, we have the naive Bayes. Now, we run now the naive Bayes using the command multinomial NB, and then we specify the alpha to be equals to 0.01. So this is now a new variable that will run our naive Bayes, and then we fit those data set that we specified earlier for X train and for Y train here. So this command will automatically compute, or run the naive Bayes classifier. And then we use we predict the probabilities using this command: pred prob train equals delays nb that predict or proba, and then we use the x train, and then the other one is for the valid. We use the x valid. Then we predict the class membership. We use the y valid pred, and then we use the dot predict, and then the x valid, and the the x train for the y train pred to predict the class membership. So we will use these variables later to show what are the results of these commands. Next, we'll add a new code cell, and we will see all the probabilities using a frequency table and then the probability table.